Hey guys, I promised you a video on the formula for the surface area of a cone and where that comes from. So I want to do that today. I'm going to start by drawing a cone. And that cone has a radius of r and it has a slant height of s. The height, of course, is in the middle. Okay? And we've already seen in class, we've been using this, I've asked you to just take my word for it, that the surface area of a cone is pi rs plus pi r squared. Okay? Now, hopefully you can see where the pi r squared comes from, because there are two faces to this cone. There is the base, which is a circle, and that's the pi r squared. And then there's the cone part, and that actually kind of became almost like a fan shape when we unraveled it, okay? Now, this is actually the radius of that fan, so that's S. And so what we really need to show is that the area of this thing is equal to the pi r s. And that's what I'm going to do right now. So before we start actually getting into that, I want to talk about what this shape is actually called. It's called a sector. So if you look at a circle and take a chunk that goes right through the middle, like a piece of pie, this is called a sector. And there is a specific set of ratios that we can set up. The sector has an area, and it also has this length, which is called the arc length. Okay? And it just so happens that the arc, maybe I'll do this in capitals actually, so that the arc length over the circumference is equal to the sector area over the circle area. Okay? So, and if you actually think about a circle that maybe we just look at a quarter of it, where we can see exactly what proportion that is, kind of makes sense. This arc length over here is exactly 1/4 of the circumference, and the area that I just colored in is also 1/4 of the total circle area. So you can see arc length over circumference would be 1/4, sector area over circle area would also be 1/4. Okay? So with that in mind, and with this specific ratio in mind, we're going to figure out what the area of this sector in our cone is. Okay, so let's just redraw that sector again and put in some more details. Okay, so one detail that I want to put in is the arc length. The arc length comes from this. And that happens to be the circumference of the smaller circle. So this arc length over here is 2 pi r. Okay, if we fill in the whole circle, I'm going to just scroll down a little bit. If we fill in the whole circle, okay, then the radius of the circle is actually the slant height of the cone. Okay, so the circumference of this circle is 2 pi s. Okay, now what we want to know is this area. We want to know that. So I'm going to label that x. And using this ratio that we've set up right here, arc length over circumference equals sector area over circle area, we can fill in everything that we know, and what we'll find is that the only thing we don't know is x. So I'm going to do that right now. Arc length over circumference. The arc length over the circumference would be 2 pi r over 2 pi s. That has to equal the sector area, which I've called x, over the circle area. The circle area is pi s squared, because s is the radius of the larger circle. So now I can use opposite operations to try and solve for x by multiplying both sides by pi when I do that and simplify the left side, what you'll see is that the 2's cancel, the pi's cancel, and so we basically have pi r s squared over s. Okay, now s squared over s, we can simplify that as well because s squared over s is just s. And so that sector area is this piece, pi r times s. Okay, and so when we go back to our formula right at the beginning, that is where this piece comes from. All right, I hope you guys found that helpful, and I will see you guys soon.